Sometimes when you are solving a system of equations, we've learned how to use substitution, where you plug one formula inside of the others, but sometimes it's not set up well for substitution. One, there's not a formula that's ready to go. Two, neither of these are even easy to get isolated so that you have a formula that's ready to go. So we've got to have a different process for that. And so we use a method called elimination, okay? So in substitution, you were substituting one formula inside of another so that you weren't having to deal with two equations at once, okay? So just to kind of refresh your memory on that, we actually plugged one formula inside so that instead of dealing with an x and a y all at once, you now set up an equation that was all one variable, okay? That was actually solvable to us, all right? Well, we still have the issue of you cannot deal with two different letters at once when you're trying to solve an equation. It's just impossible. So the way we're going to kind of use these two equations together is by just adding them as one gigantic addition problem. So when I add these together, I get 4x plus negative 4x, which ends up being 0x. And then if I keep going from there, I get 3y plus 5y would be 8y, positive 8y. And 10 minus 26, or 10 plus negative 26, would be negative 16. So if you look, when you end up with this 0x, that has basically eliminated the x's. By adding these two equations together, we have eliminated x from our situation. We don't have to worry about x anymore. And so now I have an equation that only has a y. Well, to figure out what y is, I would go ahead and divide by 8. And I get y equals negative 2. Well, that is insanely simple. Y is negative 2. Now that I know that y is negative 2, I can actually plug it into either one of these. I can either say that one is negative 2 or that one is negative 2. It is 100% a matter of personal preference, whichever one you like better. I personally like the one that doesn't have any negatives. So I'm going to plug back in to that top equation, and I'm going to say, okay, 4x plus 3 times negative 2, now that I know what y is, equals 10. If I solve through this, I get 4x, that would make a negative 6 equals 10. Add 6 so that we can isolate x, and I end up with 4x equals 16. When we divide by 4, we end up with x equals 4. So my answer to this, just to make it all nice and organized, I'm going to write them in order. X is 4, y is negative 2. Okay, so people got irritated. They're like, well, this one seems so much easier. Why didn't we just learn this method? Well, it's really not so much easier. When you were doing substitution, the first step was really complicated, but then the second step was typically pretty easy, right? Like you just plugged it right back in and got the answer real quick. In fact, some of y'all didn't even show work on this second half. So the first step was hard, the second step was easy. In elimination, the first step is easy. The second step is the one that requires a little bit more work involved, okay? But here's the other thing. This equation was really convenient because when I added them together, these x's naturally eliminated each other. A positive 4x and a negative 4x canceled each other out. It was really simple to get to this step right here. Well, in the problems that were set up for substitution, you don't see that happening. Your x's and y's aren't lined up, and they don't cancel each other out, okay? You end up with an x and a 2x, a negative y and a 4y. They're not canceling each other out. The equal signs are all out of whack, okay? So that's why we got to learn this, or we couldn't have just used this method all along, all right? So let's look at another one. 7x minus 3y equals 10, and 15x plus 3y equals 12. Well, first off, I recognize this is a really nice elimination problem because I'm already seeing kind of these that are looking like they're going to eliminate. A little different because my y's are eliminating in this problem instead of the x's. So I'm going to add these two equations together. 7x plus 15x is 22x. Negative 3y plus 3y would be 0y. My equals sign drops down, and 10 plus 12 is 22. And again, it's elimination because really once you get that 0y, it's eliminated from the problem. So now I'm just going to divide by 22, simple first step, and I end up with x equals 1. Once you know what the x value is, you can plug it into either one of these x's. It does not matter. The first one has a little bit smaller numbers, even though it has a negative. The second one is nice because it doesn't have a negative, even though it has slightly bigger numbers. So it's totally up to you. In class, most of us preferred the first one, so I'll use the first one. And I'll go 7 times 1 minus 3y equals 10. So 7 minus 3y equals 10. I'm going to go ahead and subtract 7 from both sides, and I end up with negative 3y equals 3. Divide by negative 3, so that cancels out. And 3 divided by negative 3 leaves me with y equals negative 1. Okay? Not too tricky. End up with x equals 1. Y equals negative 1. Beautiful. All right. Now, usually this is about the time people start asking, well, what if something doesn't cancel out? What if it's not eliminating? So this is kind of the baby step into this. You notice it's not, we end up with a 3x and a 3x, but if I add those together, they are not going to cancel each other out, okay? Just not going to happen. If one of them was a negative, though, that would be really convenient, right? So here's what we're going to do. We're going to change all the signs so that it will eliminate, to eliminate, okay? Because that's the only issue here is that I've got a positive and a positive instead of a positive and a negative. You can decide which equation you want to change signs on. It doesn't matter. I tend to look for, well, if there's one that's going to get rid of a negative, I'm going to go ahead and go there. So I'm going to make this a negative 3. I'm going to make this now a negative 4. And I'm going to change this to a positive 7. So I get negative 3, negative 4, positive 7. Change all those signs all the way through. Now it should eliminate. So I'm going to add them together. Negative 3x plus 3x gives me that 0x that I like to see. Negative 4y plus 6y makes positive 2y. Equal sign drops down. Positive 7 plus 15 makes 22. Okay, this eliminates, so I can ignore it. Divide by 2 and divide by 2 so that that cancels out. And I end up with y equals 11. Halfway there. We know what the y value is. Now to get the x value, I can plug in an 11 anywhere I want. I tend to get a little nervous when I've changed an equation about, well, what if I mess that up? So I'm going to take this 11 and I'm going to go into the second one just because I didn't mess with it. So maybe it's a little more reliable in some ways. So I'm going to write this equation, 3x plus 6 times 11 now, just plugging in that y value, equals 15. So pretty quickly, 3x plus 66 equals 15. Subtract 66 from both sides. So 3x equals 15 minus 66 would give me negative 51. And then I'm going to divide by 3 to finish isolating x. And x would then equal negative 17. You might have to do some long division on that to figure out 51 divided by 3. But that's where you go. All right, so x equals negative 17, y equals positive 11. So just a general introduction. There are more additional tricks and things to be aware of, but for right now, that gets us started. If something eliminates, add them together. If it just needs a sign change to eliminate, that's fine. You just have to be sure to change all the signs all the way across the equation, okay?